Hello everyone, let's create our expense API with Golang. So now let's create and initiate the module first. What we can do when initiate module is as easy as go mod init and then your module, your project name. Usually we are starting with the github.com based on your repository like this, and then Soren, and then me expense Golang like this. That's possible, or just me expense Golang also, it's okay. So me expense Golang, that's okay. So now what the library we need is, we are talking about Goqu and GoFiber as a web framework, and then Goqu is a query builder, and Postgres as our database management system, and then Go.env as our env loader. So go get github.com GoFiber v3. We are going to use v3 because this one's the latest one. And then go get github.com Doug Martin Goqu v9, and then go get github.com and then libpq github.com, go get github.com and then Joho go.env. Alright, all library should be completed, added correctly, right? Okay, so now we are going to start our project creation. And one thing you need to know is we are going to use clean architecture in our apps. So we are going to see how we create the service, how we create the repository, and etc. So usually we have a directory called as internal. So internal here is to make sure that if, let's say, your apps or this one as your project is included in another project, that project is not going to use the thing in the internal. So all the internal thing is they cannot use that. Okay, and then here we are start with the connection. So to put all the connection to our DB, connection to our Redis, etc. But now we just connect to our DB, and then we have the configuration here. Inside the configuration we will have the model and also the loader. I think just config also is okay. This config, and then we create a type with the config here, struct, and then we have the database configuration. For the database configuration we have the host string, struct. We have a host, we have port string, we have user string, we have pass string, we have name string. So at least we have these 5 for our configuration DB. And for database, of course, we are using Postgres, because you see we have the library libpq. And then we go to the config struct again, and then insert the database inside the struct. Alright, so now we are going to create a new method to initiate the configuration, and then we get that configuration from our env. So function get, that's it. So why we put get here because inside the config we already know that one is the configuration. So if we get here mean it's configuration, that one we need to get. All right. So now here we will have for example empty, because we just get the configuration, and then we load the env using the go.env load. By default it will read from the .env inside the same directory. Okay, so if let's say we got an error here, we can just block fatal with error failed to load go.env, I mean the env file. Okay, and then we will return a configuration here, config, and return config, and then database, like this. So we can just read all the env here. Let's say we create the env file, we name it as .env, and then we create a db host, db port, db user, db pass, and then db name. Okay, and for db host we can just put in your host 5432. This one is based on your configuration in our db, I mean in your local. So if you are using the port 5432, then just put inside here. But of course you can change to another port and then change to this also. But this one is the default configuration, default port in the Postgres. Okay, and for DB user we just follow Postgres and Postgres. So these two also based on your local machine. So let's say if your local machine have the different password, just put it. Okay, and then I also have create a new database here called me expense, and then one table transaction with ID, title, amount, and created ad. So we just put me expense, and then that's it. Go to the config again. We have the host. How to get the env as easy as os.get env. Why we don't really get really to go.env? Because go.env it will load to the os level env. That's why os.get env will be have a value. Os here is a library, standard library from Golang, so it will be easy. Okay, alright, we will have host and port. You will get it from db port, of course, and then we have user os get env, and then we have the password here get env, and then we have name os get env. All right, so we change the placeholder using what we have in our env file. We have a db name, and then that's it. All right, now we are going to go to the connection. We will create a database connection here. All right, so we can just get database because we are already inside the connection. Then connection.get database will make sense and sounds idiom. Okay, as a parameter we need a configuration config database, and then I will return a db connection. All right, so we will have a connection URL, connection URL here. As a connection URL, I will printf and then host as from string letter, host and then port and then user, and then we have the s here, user and password, and then we have the s here, and then db name we'll put the s, and then SSL mode we'll have disable it. And I forgot to have the host here, I will remove it, add as. Alright, just pass all thing whatever you have here inside the configuration. You have the CNF and then host, CNF port, CNF user, CNF password, and then CNF name. That's it. Alright, and then we open the connection using the DB, let's say, or a connection. The DB, I think that's okay. And then we have the error here. We are using the SQL open and Postgres as our driver. Oh yeah, don't forget to update the import, so that we need a GitHub lib pq and then put underscore in the prefix, so that later we just input the pq without using it explicitly. So the driver SQL will using that driver, but we are not going to using the pq, etc, etc. Alright, and then set the connection URL. Then if let's say error happen, we can just log and doing fatal fail to connect to database, and then we show them the error. And then here we will have the ping connection checking. So ping, let's say if we have a problem with our connection, it will error and throw error here. So check again. If something happen, fatal fail to check connection, and then we show them the error and return the DB. Alright, easy, right? And then we'll go to the root folder and we create new file, call it as main. We create as our entry point here. So function and then main. Function main. Okay. So Golang is very easy syntax, right? You see from here and from start, they have a very simple syntax, and you can really understand if you read that. In maybe 1 week you learn Golang, you have clear knowledge about that. So now we have the configuration here. I will get it from config get, and then let's check our connection using the connection and then get database. If something happen and that one get error, it will got error here. Alright, sounds good. So that means all configuration is correct. Okay, we will have the config and connection. Now we will define our domain here. So domain, we will define all the thing that will never change. We just extend that. So here we will define the interface and then the database entity. We call it as transaction. We create new file as a transaction, and then we have the transaction struct here as ID, and as I have a DB, and then title string DB title, and then we have the amount using the float 64, and then we have the created at from time as DB as created at. Alright, let's create our transaction interface, repository interface. What we need maybe the just find context, and then we will return all the transaction here. And then we have the find by ID, so that we can search by ID. ID string, then we have the transaction, and then error. And then the third, we will have the method to save or to insert. Context, we have the trx, we'll have it from transaction and error. Last, and then we have the delete context, and then ID string, and then error. So all the struct, they have at least these 4 method. They will call it as transaction repository. So different with other programming language, which is we need to implicitly talk that some struct or some class is implementing the transaction repository. In Golang, that one is not mandatory. We didn't implicitly define that something is implementing the transaction repository. Okay, let's go to the internal again. We create new folder here as a repository, and then we create new file as the transaction, and then we create struct as transaction struct. We need a DB from Goqu database. So Goqu database will have ability to create a builder and to create a query for our, so that we didn't really see how to implementing that, how we create the SQL. So if you look at the domain transaction here, I don't care if the implementation using Goqu or Go ORM, whatever. But in the repository layer, this one is the concrete. So that means this one we can replace whatever we want later, as long as we are implementing all of this. That means it will implement the transaction repository. Alright, we create how we define, how we initiate the repository transaction here. I need at least SQL DB, and then it will return the transaction repository. But what we need to return is not transaction repository, but transaction here. Goqu new default, and then connection. You can see here, what we need to do is implement all the method what we have: find, when by ID, insert, and delete. So here context will import. Okay, let's start coding. We'll change to the rest, and then error. We'll have the error here, tdb from transaction. Maybe I will select ID, title, amount, and create that. And then I will order it using the created at the scanning. Alright, and then scan struct context, will have it from context and put the result inside the rest. Just return it. And then find by ID, it will be easy. Error, and then tdb. Wait, change the data to rest first, and then from transaction we will select the ID, title, amount, and created at. Why we need to explicitly define the selection here? Because some days if we insert new column, it will not break the current implementation. And then here we will have the where Goqu C, we will have it from ID. And then scan struct context, we will put inside the rest. Alright, just return it. Go to the insert, Same goes with the insert. We'll have the error here, tdb insert. Wait a minute, I need a error here. So insert to the transaction and then row from the trx. And then we need the executor and exec context from context. Okay, we need to go to the delete first, and then tdb delete. What we need to delete is transaction, and then where Goqu C ID equals to ID. Okay, then we execute again, and then we execute context. We return. Alright, that easy, right? We have create all the method what we need. Delete, insert, find by ID, and then find. Alright, so now we're going to define the API here. Actually, you can create another layer as a service. That one will be easy, but if you want directly call it at the repository from your handler layer, that one will be okay also. But my suggestion is we create new services. But what you can see from here is how we using the repository first. Alright, go to the API, and then we create the transaction, and then we type transaction here. We need the transaction repository as the transaction repository here. So function new transaction, we need it from Goqu, app fiber app, and then we have it from transaction repository. So we inject the transaction repository here. Okay, and then we will have it from handler from the transaction. Okay, then we just maybe define new word as its API transaction, and then we create a new handler. We call it as index maybe, and then fiber ctx, and then we will return error. So h index. Alright, maybe we can just using this. Okay, usually we have the cancel context here, so that if let's say the process is having more than 10 seconds, I will cancel the process. Maybe something happened. For example, they will have DB locking or something happen, so that they need more time. I will cancel all the transaction, all the process. Okay, we have the response here, res, and then we have the error t from transaction. We will have it from find c, and then if error happen, I will just return the ctx JSON fiber error, fiber map, maybe message from here, and then we return the ctx JSON. Okay, here we can just create new folder as a DTO, so it will be easy for us to define the JSON value. Type transaction data struct. Maybe we have the ID string, we have JSON, we have the title string as the JSON, and then we have the amount float JSON. Then we have the created at time JSON. Okay, and then we go here, we have the data here, and then let's define the rest, make the DTO and then transaction data. We looping the data itself, and then we append to the rest. The main DTO transaction data, ID from ID, and then title from title, and then amount from amount, and then created at from created at. Alright, we just put the rest here. Okay, let's go to the main Go file again. Let's define our repository transaction repository. We got it from repository.new transaction. We get it from DB connection here, and then we have the API new transaction. We have fiber app, fiber new, and then we pass the app and then transaction repository, and then we just run the listen. Let's say we will run to 0000 all the interface, and then run inside the port 9000. Okay, let's try. Go run main.go. Okay, looks good. Go to the basement and then call that co-host 9000 and API transaction. Okay, sounds good. Looks good. We have the ID, right? Maybe title and amount and created at. Send again. Oh my god, we have this. That's cool. One shot. Okay, go to the transaction again. We will have another method, transaction, and then show. Maybe create ctx fiber context error. So here we have the DTO transaction, or maybe create transaction. You have the struct and then title string. I need the amount float 64. That's it. And then go to this again. We have the cancel context with timeout. Context, we have the 10 second. Just defer it. Cancel. And then what we need to do after this is we catch the request. We get it from the REST request body. So if error and then ctx bin body, we'll have it from request. If something happen, I will just return the send status unprocessable entities. Maybe something wrong with the JSON. And then maybe we have the TRX domain transaction with the ID from the UID string, and then from title from request title, and amount from request amount, and then created at from time now. Okay, then we need to check if something happened here after we insert it TX. Then if something happened, the error neo can just return the ctx JSON go fiber.map message is error. Okay, can just return ctx send status http created. Alright, looks good, right? No error. Oh, see. Okay, we have the app post API and transaction edge create. Okay, looks good. We restart our apps again, and then we create new method, new path here, and then we put as title tng top up amount is $5. We send it, we get it. All right. That's easy, right? Okay, next one. How we find by ID. How we find the transaction using the ID, the detailed transaction from the ID. We get from transaction and then show ctx fiber context. We have the error. C cancel context with timeout 10 seconds from context 10 seconds, and then we defer cancel. Okay, what we need to do is we have the data and then the error. The transaction find by ID, we get it from ctx params ID. So if you look at this, we get the API transaction and then ID. ID here we call it as params, path parameter. So if let's say something happen or something error here, you can just set the JSON fiber map, and then message will be data error. Sorry. Okay, here, if let's say the parameter or the ID is not found, it will return the data with the empty. So maybe we can just check if the ID is equals to empty, and then I will send them the error. Maybe this one should be status, right? So that HTTP status internal server error, but here HTTP not found, HTTP status not found. With the JSON fiber map message transaction with ID fmt sprint transaction with ID not found, ctx param ID, and then we just return the data, maybe using the REST DTO transaction data. We get it from ID data.id, and then title from title, and then amount from amount, and then created at from data created at, and then we return the ctx JSON using REST. Alright, go to the route definition again, and then we show it. We restart the apps again, go to the method, new tabs, and then maybe we insert this dd. We send, got it. Why always get success? Okay, last one. Let's define how we delete the transaction. The transaction, and then destroy ctx fiber ctx error. C cancel context with timeout context, and then 10 seconds. We cancel it if something happen. ID got it from ctx params ID. Data error, the repository find by ID, ctx means C ID. Maybe something happen, error, we just need to return ctx status HTTP internal server error, with a JSON fiber map. So message here, we call it from error message. If the data empty, we can return status HTTP status not found, and then we have the JSON fiber map with the message fmt spinoff transaction with ID not found data.id. Alright, here just need to return the transaction delete GTX and ID. If something happen, just copy the ID again, and then does it send status HTTP no content status no content. Alright, go to the root dependency again. We delete something API transaction ID and H destroy. Okay, we run the apps again. We create new tab, and then method will be delete and then send it not content. We go here. Alright, remove ID. Easy, right? This is how we create our apps with a clean architecture. Of course, if you want to be more clear, we have something like this: transaction service and then interface. Maybe we can just have the CRUD here, but it's depend on your preference. If okay with this, then okay. But if let's say you want to have another thing, for example here how we define and then make less redundant, we can just whatever you want. But you see here, Golang is have a easy syntax.